So this is the review of last class. So today we did opening, closing, dilation, erosion. So basically, erosion is removing the boundaries of your image. So here's our image here, A. Uh, so if we had to erode this, we're gonna remove the boundaries or the extremities. So that's like hair, 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 hair. Yeah, so basically remove the outline basically, and you only keep the inside, which you can see over here. That's just the inside. So that's an erosion. And then from here to here now is a dilation, which is basically duplicating the same your shape, duplicating it in um, positions of another array. So in this case, we duplicate it according to B. What I mean by that is, so this is our new shape to dilate, and our B is a star or a cross. So our B is an array, with your cells and stuff. Like this is your B array, it's a 3 by 3, and it has dots in these positions. So basically you take this line, this is the center here, you also come to the top here, you draw another line. It has to be the exact same line, so I have to take up the same number of cells. Right, then you go to the bottom. So you just went to the top, now we go to the bottom. Draw another line here, then you go to the right. Where's the center again? Yeah, center is here. So you go to the right and you draw one hair. Then you go to the left and you draw one hair. However that's supposed to look. However, whatever the right boxes are, you draw these. And then you should end up with this one. If I'm correct, of course. So that's it for that part today. Yeah, so let's continue. Oh, the woods are just notes, so I think I can ignore the woods. I should be saying everything the woods say, so I can ignore that for now. Okay. Oh yeah. So opening, by the way, so the basic operations we learned are erosion and dilation. Opening and closing are just a combination of the two. So opening means you erode first, then you dilate, and closing means you dilate first, then you erode. So for this one, we closing, so we dilate first. And dilate means, duplicate into positions of another array. I don't know if I'm phrasing that correctly, but that means you take this image here, and we still use the star for B. So that means you're gonna come up here, like this guy hits here, right? So we're gonna come up here, and then we're gonna draw. Let's say this looks like an E. So that looks like an E, right? Come up here, and you draw the E. So this will be the same top line here. So you draw your E, and it's gonna look like this, and do this here. So then that one would be your top, then do it at the bottom. So that means you started here, so now we come down here, draw the E again. However that shit's supposed to look, one at the bottom. Then we come to the left, that means here. Is it there? Is there where I started by? But if it's there, then come to the left, you do your E, and then I think it's supposed to be to the left now. Then you go to the right, and you do it again, and like something like that, right? And then when you finish, you will end up with all of these dots in here. So that'll be a dilation. After your dilation, then you erode. So then you start removing boundaries. I guess let me just give a disclaimer. I haven't actually went through what I'm about to say, so I don't know if it's exactly correct, but I think conceptually it is correct. Yeah, and then you remove all these, so you should end up with this, which looks already a little different, which means this is supposed to be gone, this is supposed to be gone, this is supposed to be gone. So this one, yes, that's correct. Well, you keep this one, 0, 2. Yeah, I guess you keep that one. So it's something like something like that. Yeah, sorry, it might not be, everything might not be 100% correct, but conceptually, that's what's up. Just erase this. Okay, right, so Sir also mentioned that this was a mistake in the textbook, so that's actually wrong, but these two are correct. So it was like quite literally a mistake on that one. Alright, that's closing. Okay, noise removal. This part I didn't really get the gist of what Sue was saying here, I'm not gonna lie. But he did said, use 3x3, not 5x5 usually. And then for skeletonization, the process is basically erode, subtract, save. And you run it 3 times, and then the final product from your 3 times, you just combine it. That's how you do skeletonization, and it's used in detecting handwriting. So let me just show you the process. So first you have A, right? First you have A. So you erode, which means you take out the extremities, and you end up with this. Not exactly perfect, but yeah, you remove some extremities, to say the least. So now that you have this eroded part, let's call that A's erosion. Then you subtract A from A's erosion, and then you get the extremities that you removed, right? So this is your first save right here. Then I guess maybe I don't need to actually draw at this point. There we go. So this is your first save here. Then you take a. Wow, this is kind of confusing. I asked Chad about this, and it said yes. So I guess I'll go with that. But here, this is a sign for erosion, by the way. The minus the line of the circle is called an erosion. Yeah, it's called an erosion. So technically, this is A's erosion. The reason I'm wait, yeah, and this is opening, huh? So we erode, then dilate. Yeah, because opening is the white circle. Yeah, opening here is the white circle. Closing is the black circle. So that means, okay, so I guess never mind. So we don't only just erode. My fault. So this is wrong. So this is not just erode. This is actually open. Open. Then you subtract the original from the opened version. So open, subtract, save, I guess. My fault. So then open, subtract, save. You get this. Then you erode. Yeah, you erode A with B. And then you use the dilated version and you open it with B. Okay, cool. Yeah, you open it with B here. I'm just looking at the notation. Open it with B. Then you again subtract this dilated version, which is here. Subtract this from it, this from this, and then you get this. Yeah, that kind of makes more sense because I felt like this was a bit funky. Because I was asking Chad if I erode A to get hair, and then I subtract the two to get hair. How do I get hair? If this is just the same as this, why does it look different? But that makes sense. This is opening, this is erosion. Right, cool. So erode, then open, subtract, save from this point. And then from here, you erode again, it looks like. Erode again, and then you open it, yeah, open it. Then you subtract the erosion from the opening. Yeah, and then, so these are your, so these are your 3 saves, right? and you just combine them, and you get a Christmas there. That's what Sue called it. And yeah, that is handwriting detection. That's where it's used. I guess I'll fix that in my notes when I'm finished with this video. And then we also did this grayscale morphology thing. This one was a little funky. So I understood this part. Let me erase that one time. Pause to erase. Right, now for grayscale morphology. So this one was a little interesting. So here's what you do. This is your original A. Right. So you get your, well, you have a mask matrix. You're going to put this mask matrix on every element in your original, and for her we're going to do it from one, I guess, point of interest or whatever. So when you put this over here, so 3x3 mask, so here, then you subtract your mask from your original. So it's going to be 1 minus, well, okay, top left minus top left, 0 minus 0, 1 minus 0, 1, 1 minus 0, 1. Since this is all 0, you're just going to get the same thing for this case. And the minimum value in this entire matrix is what you're going to replace the elements with. So actually, I think I messed up here, sorry. So I think it erase, so it has to be like this. Yeah, because you only replace in one element in the end, and it's going to be the center. So when you're doing this one, you put in your mask like this, so that the center of the mask is in your point of interest, is on your point of interest. Do your subtraction, blah blah blah, you'll get this result. Right, 3 zeros, 3 zeros, 3 zeros, 3 zeros, 4 ones. Well, the smallest number in this matrix is a 0. So then you replace this with a 0. That's why you have a 0 here instead of a 1. And yeah, you do that everywhere. So if we had to do another random one, I guess maybe let's take in, oh, this is all ones, so it's not gonna be a change. Let's see, let's try to do some reverse engineering for this one. This is our point of interest. So this is 1, 2, 3, 4, 5, up 1, 1, 2, 3, 4, 5, up 1. This guy. So take this, subtract it from zeros, so you get the same thing. Smallest number is a 0. So then you put a 0 in this position, which is why you have a 0 over there. So that's how that works. That's pretty simple. This is erosion for grayscale morphology. Then you have dilation for grayscale morphology. And he said it's the same, but instead of subtracting, you just add. And then, actually, I lie. It's the same, but you add, and then you take the maximum, I think, if I'm correct. Yeah, I know you definitely take the maximum, but I don't know if this example is slightly different from just grayscale morphology dilation. Because if it is, then maybe you don't take the maximum for just dilation. Okay, but let me just explain what's up. So this is for erosion. For dilation, quote unquote, is the same, but just add. Alright, and then later we did an example also of dilation. So I don't know if this example is something more specific inside dilation, like, I don't know, maybe. I hope I'm not doing more confusion than clarifying, but hopefully you know what I mean. So for this example is a bit funky, which is why I thought it was different from this one, but I'll show you why. So I'll show you the example. So this is your mask this time, and yeah, so you take the center, put the center in here, and then you now have 10 over 5, we're doing dilation, so we're going to subtract in this example. Yeah, we're eroding. So we're doing erosion, so we have 10. I guess let me highlight. Holy shit. 10 minus 5. So you get 5 in the center. Alright, now this is your mask, because it's a 3 by 3. And of course, note that this and this are not elements. Like, this is the outside of your picture. So you're only really working with these 4 elements. So, but still gotta work with your mask and stuff. So you're working with these 4 really. Yeah. So you have 20 minus 6, which is 14. 30 minus 9, which is 21. 20 minus 8, which is 12. Then you choose the minimum, and that's what you have here. And you basically do that for the entire thing. I'll just do one more. Let's do one more. Let's take 17. 17 is in what position? 17 is supposed to be the middle. 1, 2, 3, 1 down. 1, 2, 3, 1 down. So that means we have 5 here, 6 here, 8, 9, 4, 7, 1, 2, 3. Great. Okay. Should I do this? But I don't want this video to be too long. Alright, let's do it. So 35, middle you have 25, 46, you have 34, 20 and 3, 17, ooh, lucky number, 22, 18, ooh, I might be writing this in the wrong order, sorry, I get a bit careless when I'm rushing. Let me go again, 35, 25 in the middle, 46, 34, 38, 30 and 8, 22. Please. 22. You know what? Nah, I'm not gonna. This is gonna take too long. I've explained the concept. Okay, just apply it. Just apply it to the other points. I don't want this to be too long. So this is dilation, and then sorry, that's erosion. And then for dilation, you add, and I think you choose the maximum. That I'm not 100% sure, so let me try it right now, so you can figure it out together. Take this one, for example, 39, 2, 2, 2, 2, this guy. So this guy is my middle. 5, 6, 9, 8, 7, 4, 1, 2, 3. So let's do some adding. Middle first. 30 and 5, 35. Then next to it is 30 and 6, 36, up 20 and 3, 23 to the left, 20 and 2 to the left again, 10 and 1, 11, down 20 and 4, 24, down 20 and 7, 27, to the right, 30 and 8, nice, then to the right, 30 and 9, and then take the maximum. Yeah, so it is the maximum, so you get that here. Yeah, so that's what we learned today, basically. Well, that's about all I got from today, at least. And yeah.